Let's solve LeetCode 22, generate parentheses. Given n pairs of parentheses, we want to write a function to generate all combinations of well-formed parentheses. So the example one is n equals 3. This is the output. How is this the output? Well, that's because we have 3 opening and 3 closing parentheses, and we write out all of the combinations of that possible. So first we go ahead and have 3 opening and 3 closing. Then we have 1 opening and then 2 pairs of parentheses opening and closing. And then the final, like the first parenthesis itself closing. So what we're trying to do is, let's say we have something like this done initially. After that, we go ahead and do something like this. And then we do something like, I think it would be like this. I don't know how to create it, but yeah, think we can just do this. Yeah. So like you need to keep going and like create all of these combinations. They are all valid parentheses. That means none of them are like incorrectly placed. So you don't have something like this done where, it's something like this done. So this is invalid. The reason for it is because you have 1 pair of opening closing, then you have another bracket, but that doesn't close. So that's invalid. And you need to create essentially 3 opening and 3 closing. So 3 pairs of parentheses. Now, how do we create that? Now, I'm directly going to jump into the solution because I think it's not very intuitive. And the approach is called the backtracking approach. So how does this backtracking approach work? Well, the approach works this way. Let's say the n is given as 3. Let's write down the variables we have. N is equal to 3. This is the only variable that's given to us. All right. So this is going to remain as a constant. Another variable that we are going to create ourselves is called the open parenthesis. So how many open parentheses do we have? Initially, it's going to be 0 because we're going to start with an empty string. Then our closed parenthesis is also going to be 0 because we are going to start with 0, an empty string. And now we want to essentially, like the main intuition of doing this is that we first of all create this string, then we backtrack. So first we create this string, then we backtrack all the way so that we can find all of the combinations possible. Now, how are we going to solve this? Well, as I said, first we need to create the main string from which we can backtrack. So I'll have a string that looks like this. Okay. How am I creating this string? The logic for it is that, hey, as long as the open parenthesis that I have is less than n, what I'll do is add the open parenthesis to my array. And this is the array that I'm going to maintain. This array is going to act like a stack. So I can only append to the last element. So like to the array, I can only append the last element and I can pop the last element, nothing in between. So it essentially acts like a stack. So let's say my result is over here. And this is not the result, actually, this is the stack. Result is going to contain multiple strings. This is going to be the result. But the stack is one string that we are going to create and put it in the result variable. So whenever the open parenthesis is less than n, what I want to do is append to this stack this thing. And then what I want to do is call the function recursively. Because I don't want to do it once. I don't want to do it twice. I want to do it as long as open p is less than n. So what I can do is create a recursive function that calls itself. And then we are faced with this logic continuously. When calling the function, I'll increment the open parenthesis by 1. The closed parenthesis will remain as it is because we're just appending the opening parenthesis to the stack, correct? The next condition we'll put is closed parenthesis should be less than open parenthesis. Why is that? That's because what we want to do is something like this. So let's say this condition is executed, right? So initially the 0 turns to 1, 1 turns to 2, and 2 is less than 3. Cool. And then we have 3. 3 is not less than 3. So we move to the next if condition, which is closed parenthesis is less than the open parenthesis. So as of now in our stack, we have a string that looks like this because the number of open parentheses is 3. The closed parenthesis is 0. Cool. Now we want to check that, hey, if the closed parenthesis is less than the open parenthesis, so that means 0 is less than 3, and that is the case, then what we're going to do is append a closing parenthesis. So I have closing parenthesis, and this is also called recursively, where the open parenthesis remains as it is, but the closed parenthesis increases by 1. Cool. So now I have 3 closing parentheses. And then at the very top, the base case of this recursion that we are doing, we're going to check that, hey, if the open parenthesis is equal to closed parenthesis is equal to n, that means we have an answer with us. So what we'll do is create a result variable, and in that result variable, we are going to append the string that we have created so far, which is this string. Cool. Now comes the main part. This is just the formation of the first string. The first string is the easiest. Now the complex logic will come in, and that is the backtracking logic. We have not implemented backtracking yet. As of now, what's happening is just stuff working out to create this string. But now backtracking will come in. Now, how does backtracking work? Backtracking works in the way that, hey, if you go forward, then you go one step backward and try another combination. You go backward, try another combination. Go backward, try another combination. So remember, I had told you this is going to be an if condition. If the open parenthesis is less than the total number of parentheses required, or the total number of pairs that are required, we're going to call this function recursively. What we're going to do is also pop from the stack after we've called the recursive function. Why? That's because when we call the recursive function, it doesn't go directly to the next place, right? It directly calls the main function. So let's say the function was called backtracking. So what it would do is call the backtracking function, again execute this line, then again it would go here, again execute this line. Once it's done 3 times, this condition is no more true. We go to this condition, which is another if condition. So if closed parenthesis is less than the open parenthesis, we're not checking with n. The reason we're not checking with n is because we don't care about it being less than n. We only care about it being less than open parenthesis. The reason we care about it being less than open parenthesis and not n is because if you look here, the number of open parentheses we have should be equivalent to closing parentheses. Like imagine you have 2 opening parentheses and you compare with n over here instead of open parentheses. So what you have is something like this, and this is invalid. The closed parenthesis should be dependent on open parentheses. You can only have, let's say, 3 closing parentheses if the open parenthesis is 3. If you have 2 open parentheses, you can only have 2 closed parentheses. You can't have more than that. Closed parenthesis is dependent on open parentheses. But for open parentheses, that's not the case. You can have 1, you can have 2, you can have 3. What open parenthesis depends on is the constraint of the problem, which is how many pairs do we want to create. Based on the number of pairs we want to create, I can just go ahead and add as many parentheses as you need. And then close parentheses will just end it out, determining how many, close parentheses we need depending on this thing. Cool. So having understood that, what do I want to do? Well, coming back to this condition, let's say I've put in 3 parentheses, the opening parentheses. And now what I want to do is, well, we've exited out of this condition. We are in basically a recursion call. So there's a stack frame over here, which has called the function multiple times. So let's say the backtracking function was called like this. So 0, 0 initially, then it was 1, 0, then it was 2 0, and then it was 3 0, correct? Where 0, 1, 2, and 3 are the opening parentheses, the number of opening parentheses. And they're in the stack frame because you've called recursion, and the program is yet to be completed. The program is yet to be completed because there's another if condition. It's not an elif condition. It's purposely an if condition. And what this if condition is doing that, hey, based on the open parentheses, I'll add the close parentheses. So now we'll go ahead and add this, correct? So now we have b 3, 1, b 3, 2, and b 3, 3 because we executed this if condition. And that's how we have our stack frame. Cool. Now we want to exit out of this back frame, and we'll get out of this back frame by, backtracking. So what we'll do is here in the if open parenthesis is less than n, once we've called the function, we call the pop. And even over here, after we call the function, we do pop. Okay. So here, once we have b 3, 3, there's nothing more to execute. We'll reach this condition, the base condition of this backtracking function, which if you remember, if open parenthesis is equal to close parenthesis is equal to n, that means we have valid pair. What we're going to do is return. So now I will happily return out of this function. And by the way, my result variable is also updated with the correct parenthesis, like the correct string, but we're not caring about that as of now. I want to take you through this stack frame. So yeah, this function has completed executing. So it will pop out. Then we go to b of 3, 2. So we start from where we left off, right? When this function was called with backtracking 3, 2, correct? So we now execute the next statement, which is pop. So now once we pop the stack, what we have is this changes to something like this, correct? We no longer have a closing parenthesis with us. And then this function also executes. It's done. Now we only have b 3, 1. The same thing will happen here. Here backtracking 3, 1 was called, and then we popped out of the stack. So what we'll do is this will get converted to this, okay? And then we finish b 3, 1 as well. Great. Now we have b 3, 0, okay? So that would also mean that, we have to exit out of the open parenthesis. And yeah, so we'll essentially go this route where we only have the 3 parentheses. All right. Now, what's the next step that we can do? We can also exit out of this function, and then what happens is we start from this function, okay? Because all of the close parentheses have been popped off. There's nothing more. We are starting off with this thing, which was related to open parentheses. So now open parentheses will be popped off. So this thing also goes away, by the way. So this will get converted into this thing. And now the magic will come in. Now we need to put in closed parentheses. And here, once the stack.pop for open parentheses is completed, we go to the next if condition. The program hasn't executed yet. Like, it's not finished yet. The function is not finished yet. We still have the next if condition to go through. If closed parenthesis is less than open parenthesis, then what do? Well, we will just go ahead and execute this particular line, which is backtracking of, well, now we have 2 open parentheses, right? And 0 closing parentheses. So we'll increase the closing parentheses now, and we'll add it to our stack frame. So now we have b 2, 1. So now our thing looks like this. And then we again go through all of the conditions. Open parenthesis is less than n. So we'll have another opening bracket here. So we also have b of 3, 1 now. So this will be stored in the stack frame. And now we reach the condition that open parenthesis is less than n. So we go to the next condition. If close parenthesis is less than open parenthesis is 3. So what we try to do is add the close parenthesis. And then we again add another close parenthesis, and that is our result. That's the second result, correct? If you remember here, we have this particular thing. Great. And then we'll again, pop off, because now we are again reaching B3, 3 essentially. So what we'll do is pop out of this, pop out of this, pop out of this until, the close parenthesis again goes away. And then we'll again go ahead and remove the thing. So we'll remove this. Cool. We'll remove this. We'll also remove this, I think. And then we start from this part again, and then we'll keep on going. But you get the core logic over here. We are depending on open parentheses. So when we are trying to add open parentheses, we are depending on n. When we are trying to add close parentheses, we are depending on open parentheses. And then we're continuously backtracking. And for backtracking, essentially what we're doing is appending to the stack, calling the function, and then popping out of the stack. So that, it is almost like we never visited this element. So let's go ahead and solve this. So the very first thing I'm going to do is create a result variable at the top. Then I'm going to create a function, backtrack, which is going to be a recursive function. And here I'm going to have open parenthesis, closed parenthesis, and then, n is already given to us. It's going to remain as a constant. So I don't need that. Great. After this, I just need to check that, hey, if the open parenthesis is equal to the closed parenthesis is equal to n, that means we have a solution with us. So what I want to do is also create a stack variable outside of this function, because if I initialize it within the function, it will get reinitialized every time, and I don't want that. So what I'll do is, well, this is an array, right? Which is going to contain stuff like this. So what I want to do is just join it. So I'll have dot join done to this stack, and then I can append it to the result, because that is my thing. And I'll return out of this backtracking function, and we're all set, because as soon as we reach the number 3 or the number 1 in this case, I want to get out. And so I want to get out because I want to stop the execution over here so that I can go back in the stack frame. That is our base condition of this recursive function. The next thing is that, hey, if the open parenthesis is less than n, if that is the case, we need to add more of this bracket to the stack. And once that happens, I want to backtrack. So as soon as we add it, I'll backtrack. And I have open parenthesis +1, and the closed parenthesis hasn't changed, so it will remain the same. And then we'll pop out of the stack. Pretty easy. So we append it, then we backtrack, hoping that, we get some other variation. Then I pop out. So in the first try, what will happen is it will give 3 of them, right? So what happens is, like, you get 3 of these open parentheses, because you call this backtracking and this condition keeps executing. After that, this executes. So you one by one get rid of them. So essentially you get to have an opportunity to have the various, you can say various combinations of open parentheses with this approach, right? And then once you have 3, you one by one remove them so that you can try it out with other variations. And now after this, so this only sets up our opening parenthesis logic. Now I want to close it. The closing is if closed parenthesis is less than n, or not less than n, less than open parenthesis. I've already explained it to you why we need to do that. We'll just do stack.append and we'll add a closing. Then I'll backtrack this as well. So I'll have something like open parentheses will remain the same, close parentheses will increase by 1, and then I'll pop out of this stack. So just with this if condition, what we're doing is, hey, if the open parenthesis is 3, for example, it will add 3 of these. If there's 2 of opening parentheses, then it will go ahead and add 1, right? And then what will happen is this line will execute before it. Because if open parenthesis is less than n, 2 is less than 3. So what it will do is go ahead and add itself. Now we have 3 opening, and now you can just go ahead and add your closing brackets again. So this is the logic. This one will go something like this. So in the first try, all 3, okay. I hope I can remove this. And then one by one, it will remove this. Okay, great. So yeah, this is the entire backtracking logic actually. So I can just go ahead and call this function. It sort of is magical, but yeah, this is what it's like. So we'll just return result, and yeah, let's execute it and hope it works. It accepts. I'll submit. And it's accepted. The time complexity here is quite complex. It is O to the power O of 4 to the power n divided by square root of n. And the space complexity, well, we are having so many function calls, right? So it will be square root of n. Great. Again, I think the intuition here is that we want to try out every combination of opening and closing parentheses. So we first bring out 3 of open, and then we try out all the possible closing parentheses. Then we remove all the closing parentheses. Then one by one, we try out with 2 opening parentheses, we try out the closing, and then we again try out opening it again, closing it again. That's essentially how it's going. This is the entire flow. So yeah,